Hi everybody, my name is Jinxin Liu from Nanjing Agriculture University. I'm pleased to present our recent work. A little bit of background, I specialize in animal nutrition and gastrointestinal microbiota. Gut microbiota plays an important role in animal growth and health. Unlike adults, the microbiome in young animals is more susceptible to long-term modulation. And diet is a major driver of early gut microbiota assembly. Fructose-oligosaccharide is a plant-derived soluble fiber which escapes host digestion and promotes beneficial bacteria. And first modulates microbial structure to enhance fermentation, stimulate microbiome maturation, and improve host health. We hypothesize that a false supplementation can stimulate the gut colonization and maturation of the gut microbiome, and as a result can enhance gut fermentation and improving growth performance in their calves. And to test this, we conducted a longitudinal study on 16 newborn Holstein dairy calves. As shown in the table, we can see dairy calves receiving false had a higher ADG by week 4 and tended to weigh more on day 28. Meanwhile, from day 16 onward, fecal acetate and propanate levels were significantly higher in the false group. Furthermore, we observed a higher correlation between the ADG and fecal concentrations of acetate and propanate in the false group. And changes in the short-chain fatty acid levels were linked to microbiome shifts. Lipsin and random forest identified 5 key taxa: false enriched bifidobacterium doria and Alloprovitella, while Clostridium and Streptococcus dominated in the control group. We examined the genomes of false enriched microbes and found that bifidobacterium has complete false utilization pathways, while Doria lacked them, indicating indirect enrichment through cross-feeding. And we then constructed a current network linking biomarkers to short-chain fatty acid levels, revealing positive correlations for bifidobacterium and Doria. And to first explore how structural changes affect microbiome colonization as an assembly, we clustered microbiome data over time and observed a clear shift from community type C1 adverse to C7 and by day 28. And alpha diversity increased from C1 to C7 and supporting C7 as a relatively mature community. On day 1, both groups shared the early stage type C1, the mature type C7 appeared earlier in the false group, and the Bray-Curtis analysis confirmed a faster shift towards the day 28 microbiome, indicating a stimulated maturation. And based on this, we concluded into 2 points. Firstly, false promotes the growth of bifidobacterium in the calf hindgut, improving the ADG in calves. And second, false alters the structure of the hindgut microbiome in dairy calves, stimulating microbiome maturation and enhancing the ecosystem stability. With that, I would like to close my talk here, and thank you again for your attention. I would like to take any questions if you have. Thank you.